Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed at building large-scale distributed systems.
Hey, I'm Jeff Carpenter. I'm here with Josh Perryman from Expero. Thanks for joining us, Josh.
My pleasure. Great to talk with you, Jeff.
So I hear you know a few things about Graph. I think it's probably fair to say.
I've been slogging my way through this technology for a few years now.
And probably if anyone tells you that they have 20 years experience in Graph, that's one of those instant resume red flags, right? So there certainly has been maybe some presence of Graph in the research community for a while, but in terms of recent developments and recent popularity of Graph, it's been not too long, right?
That's my impression. I mean, you talked to Matthias and Marco. Those guys are probably close to, definitely past the 10-year mark. I'm counting on year 4 at this point.
Okay, but that kind of puts you at the upper echelons in terms of longevity. I mean, has been an emerging area over the past few years. And I know that you like to refer to yourself as a data junkie, right? Is that an official job title at Expero?
Up with something other than like Code Ninja and other stuff. So I ended up with data junkie. Probably need to revisit that.
Well, so flesh this out for me a little bit more, because I think data junkie is probably a fair description, but expand on me a little bit. Like, what does that mean? What's in your background?
A lot of solving interesting problems. When I first started with Expero about 6 or so years ago, the owner of the company had a client that was saying, okay, we need someone who can do high performance computing in Microsoft Excel. And his response was, that guy doesn't exist, but if he does, I'll find him. And I didn't really know high performance computing, but I learned it. And I had done enough other things in my background. So I kept kind of popping around from one interesting engagement to another. Largely, they just seemed to coincide with my bench time. And how I got into Graph was kind of along the same lines. A lot of my work has tended to focus on the back end. And so I went from being kind of a jack of many trades, I wouldn't say all, to a guy who focused on, okay, let's figure out how this data performance stuff needs to work.
So that's how you kind of zeroed in on it. Like you're solving problems for clients, helping them out, and then you reach a point where it wasn't like, hey, this Graph thing is new, and I really need to find a use case where I can apply Graph. It wasn't like a solution looking for a problem for you. It doesn't sound like. It sounds like something that you came to because you had certain problems you were trying to solve.
Well, we had a client that had problems, and they had frankly lost confidence in their developers' ability to solve them. They had an enterprise application that was backed by a relational database that was really poor performing, and it was beginning to affect sales. And so they called us in. I remember that first meeting. They called us in, and several of us were sitting around, and the product owner was saying, really, this is how it's designed. It looks like a graph. It smells like a graph. Maybe we should use a graph database. I asked my developers to try it. They tried a bunch of triple stores, but they didn't ever really try the graph databases. We'd like for you, Expero, to go in and try a graph database for us. And I came out of that meeting with only one question, which was, what is a graph database?
Awesome. Okay, so what happened? Like, how did you get into it? How did you get rolling?
I was really fortunate because the product owner is technically really good, but he was also really good at understanding his boundaries and recognizing, hey, I need technical staff just to dig into this. And they gave me a good enough time budget to work with it. And he said, here's the 3 I want you to try out. There's Titan, there's Neo4j, and then there's, what was the Allegro Graph was the third one that I looked at, which is really a triple store. It's not a graph database. And so I just took a few weeks on each of them, figured them out, threw the client's sample data into it, and started playing around with it. And that's it was the fun part about that was kind of diving into some of those technical details, but then kind of poking my head up and rehashing the results with the different people at Expero, trying to figure out, okay, why do these things work this way, and how does all this stuff interact, and is this really the right approach to solving these problems? So there's a lot of surfacing results internally and breaking those down and trying to understand how this technology really works.
Gotcha. So what were the things that kind of drove your decision-making process? You mentioned that you were evaluating multiple tools. So We know the end of the story, maybe that you ended up as having like a high degree of expertise in DSE Graph in particular, which was kind of came out of that Titan world. But, tell me a little bit about how you got there.
Well, so that was really fun about that story is in the end, Graph wasn't the right answer for them, which was kind of shocking. And this is what caused a lot of discussion internally because we were told, like, well, the right answer is to use Graph because they're clearly using the relational database wrong. And part of that was correct. They were clearly using the relational database wrong. What I did in my evaluation, and this didn't come out in the blog series that recapped it, but what I did in my evaluation was I looked at each of the three vendors, but then I also took a step back and said, okay, from what I know about relational database performance, if I were to take their example, their data, and do a properly kind of normalized relational database, how would performance work? And so we went through that. There were two salient examples that came out of this. One is when I did the examples, I then presented it to the client and showed them the code that was used. In one particular example, they had a common table expression, a CTE, that was 100 plus lines long. It had 5 or 6 different parts to it. They had multiple joins going on throughout. It was an unholy mess, and what it amounted to was a 5-hop step in a graph. And it would just go hit these 5 different types of nodes. And so I rewrote it, and I showed them what it looked like. I don't know if it was Cypher or with Gremlin, and showed them, okay, here's your SQL code, and then here's what it looks like when it's coded with the graph language. And their response was, oh my word, I can read that.
Yes.
Being like a 2 or 3 line long statement in a graph language. So one of the first things that was an obvious benefit to us was developer product. You're going to go from 150 plus lines to 5 lines with very arbitrary line breaks in there. You've now created something that can easily be reasoned over, and it's just a whole lot less lines of code to deal with. So there was that side of that. But then what we also realized was that relational database technology is really amazingly good. There's a lot of benefits that we've taken from that for decades of experience. And if you start using it correctly, they were using it in a way that neutered the query analyzer. But when you start using it correctly, then the result is that you can get some really great performance. So my normalized relational designs worked really well. And we told them what you really want to do is you want to do both. You want to use a relational database better than what you're doing right now. And then you want to eventually add a graph component to that. So I spent the next 1.5 years rebuilding their back end with their team. And after 1.5 years, we got, for some of their worst queries, 100x performance improvement using relational database. And then the next step was bring in the graph for the very graph types of access for that technology.
Right. So that's a really, really interesting case study there, which I didn't realize kind of some of the details of, which is just because something that looks like a graph problem on the surface, and actually there are portions of it that might very nicely fit, and you're saying like, hey, it looked great when we began rewriting some of these queries in a graph query language, but that doesn't necessarily mean that the graph database is the right solution on your back end for every problem. So talk to me a little bit more, because I'm intrigued here. You're suggesting that the ideal solution may in fact involve continuing to use some relational technology for some of the data, and then some graph for other portions of the data. So let's expand on that. And how did you go about determining which is which, and what stayed relational, what went to graph?
Yeah, a lot of this comes down to, and I talked to developers, and so I talked to one developer in particular. This kind of falls into that CQRS pattern where you're separating your reads and your write paths in your application. And I talked to one developer back, and he said, I've seen that, but I've never seen it implemented successfully. And he's like, I'm really skeptical that it makes sense in our environment. And I told him, I want to state this up front, just because when you take that approach, you're adding significant complexity to your application. And if it doesn't warrant that level of complexity, you shouldn't do it. And I told that developer, because I had been working with in his same domain with his same data for 5 or 6 years. I said, you're right, it doesn't make sense in the area where you're working right now. For smaller places, for places where you're not running into performance issues with your data layer and other stuff, try and keep it as simple as possible, because you have probably more complexity in your business logic than you do at your persistence layer. And so manage for that. So that's one of the things I want to state up front, is that you don't just start adding new data types or persistence engines just willy-nilly. You need to at least think through your problem and recognize and try at least push the limits of what you've got. And you should always probably start with a relational database, most likely because you can find developers that write SQL, or you can use an ORM. So that's where I'd start with things. But when you start looking into problem areas and you start wanting to reason over your stuff differently, such as if I've got use cases where I'm doing dependency analysis and I'm going 3 or 4 or 5 hops out, then I'm gonna make my relational engine fall over. If I've got use cases where I'm joining together multiple things and I want a result set that's not just apples, but I want apples and wheelbarrows for some reason, then I can't use a relational database, because then my joins and everything else get really clunky. But Graph is great for those kind of. So when you've got multiple hops, or indeterminate number of hops, so you're writing that recursive CTE, you need to start reconsidering when you're writing those recursive CTEs, or when you're trying to join together multiple different types of things to come back in the same result set. That's when you start looking at the graph.
Okay, and you mentioned the CQRS pattern a minute ago, which maybe we should explain just like super nutshell briefly in case someone's not familiar with it. But I take it that you're talking again, like you said, about separating the read and the write path, and maybe that helps you determine where you use graph. Like, help just to unpack that a little bit for me.
Well, what I really like thinking about the CQRS, or thinking about separating read and write paths, because what is the CQRS is Command and Query Response Structure or something like that. I forget what the full Command and Query are parts of it.
Yeah, people don't tend to name patterns as straightforwardly as maybe I would always hope. But okay.
Right. So I like write paths and read paths. If you're writing a logging application, the first question you need to ask yourself is, am I read heavy or write heavy? And if I'm write heavy, I'm writing a logging application where I'm just going to be throwing a whole bunch of data in some way, and you want to organize or think about that data pattern differently than as if I'm going to be searching through or querying that data. So if I'm read heavy, which tends to be where most of our applications are, they tend to be very light with writes and very heavy with reads. Now I need to start thinking about how I'm organizing my data a little bit differently, because 80-90% of my data interaction is just going to be querying. In that case, I need to optimize for queries. And the sad fact is, and most developers don't think about this, but their normal form is horrible for querying.
That's right. And maybe what we were doing was optimizing for storage, because that was the cost driver, is being efficient on our use of storage, but that's not really the world that we're living in today. Today, speed is king, right? And we got to get that read performance up, latency's low, et cetera, et cetera.
Right. Yeah, we like to talk at Expero that performance is a feature.
So am I right to say that the applicability of the graph is more on the read side then?
I think that's where it is. There's 2 main areas where I see it. One is the read side, because with the graph, this is one of those things that I've learned about graph along the way. Anytime you write that edge or that relationship, there's a write amplification that happens. You are taking, in every graph database that I've seen, this may not apply to triple stores, but at least with the graph databases, there's a write amplification. You write an edge, you're going to write, there's at least 2 separate disk write operations that are happening there. But when you do the read, they go a lot faster, because you're no longer, and this is kind of taking a step back with relational databases. Join is a runtime operation. And so when you do a join, you're pulling a whole bunch of data into memory, and you're now you're trying to figure out or sort those keys and organize them. Now, our modern query engines and relational databases are really, really amazingly fast at that. They know how to do that really well. But if you can avoid doing an in-memory operation like that and just read from cache or read from disk, you're going to be a whole lot faster than having to kind of sort all that stuff out at runtime. So that's one of the great advantages of the graph. You take the write amplification hit up front. But if you're doing a lot of reads and very unpredictable reads, like following different paths in the graph or traversing different through different paths, then it's going to be extremely beneficial. That's that, what is the concept? Index-free adjacency they like to throw out.
Oh, okay. What does that mean?
So
when I hear a new term, I want to know what it means.
So it's basically saying we're using a linked list to store our data.
Okay.
That's from in developer speak, right? Index-free means I'm not going to consult an index. I'm just going to follow the pointers from the linked list. And adjacency is things like if A links to B, then I'll have on disk source A, destination B, and I'll just read that one row out of the file or out of the row in the table.
Okay, so one question that I want to follow up on. I get the idea of separating your workload, read and write workload, of the idea that you may want to be using multiple databases, in fact, for certain pieces of that. But how does the data get into the graph? Am I writing to relational, and then I'm also writing to the graph in parallel, or I'm thinking like, and I am sort of leading toward the idea that like at least with the DataStax graph product, Cassandra comes in there, and that's not necessarily a relational. It does have CQL, which is SQL like. So I guess that's kind of where I'm going is. Are we talking about duplicating writes to multiple locations, or how do you see this working in practice?
It kind of depends on who I'm talking to, right? If I'm talking to a business owner, I'm going to say there's a data abstraction layer there, and we're just going to figure it all out for you. And your front end coders and your middle level coders, they're going to code against the DAL, and they don't have to worry about what's going on under the covers. When I'm talking to the guys, or when I'm talking to myself, I guess, it's the guys who are actually building the stuff under the covers. Now, that gets to be an interesting question. Some of it's going to come down to what engine we're using. The DataStax engine right now, I really am partial on an ETL process, data load process for using DSE GraphFrames, which makes it's a really great API for abstracting out all of it just takes care of all of that stuff under the covers for me.
All of that stuff means like multiple databases, or what is the?
Well, Cassandra, what's going on with Cassandra and the multiple tables and the graph? I'm able to think about the graph part of the problem as graph, but still deal with it in a graphy API, a graph-oriented API, but not have to worry about how do things get persisted underneath it. It integrates so nicely with the DSE Graph and so DSE GraphFrames is a really neat API. If it's more transactional, then maybe I'm using Tinkerpop. I'm working with DSE Graph. I'm really reluctant to edit the DSE Graph Cassandra tables directly. I might read them directly from time to time just because I like to see how things are stored on disk. That aids in my modeling. I would never go in and hit those Cassandra tables, write to those Cassandra tables directly. I'd prefer to use an API that's a vendor provided one. Now, if I'm working with SQL Server, on the other hand, that's now added a Graph API access to their stuff, I will probably, in that scenario, write to the tables with my SQL, same type of SQL stuff, and then their API allows some graphy abstractions to be introduced on top of that. So that some of this is very vendor specific, right, in terms of trying to understand what does my vendor allow, what did you do. I wouldn't be surprised if my buddy Ted, who was on here a few episodes ago, when working with his open source tools, prefers to just hit the tables directly or understand stuff. Ted will do some crazy stuff. I prefer to run with training wheels.
Yeah, no, I hear you. I mean, there are definitely virtues of kind of going with direct access for speed, kind of at your own risk. Maybe it's less maintainable code or over time. So that's the trade-off that you're making there. But I do like very much the point that you made earlier about kind of offering up those abstraction layers and using patterns like a DAO, data access object pattern, to hide some of the gory details of your database implementation. And then you're separating that out from your business logic. It can continue doing what it's doing. You do need to be conscious of things when you're writing that DAO layer. And that's kind of where where I want to take the conversation, or where I want to ask you about is like, I think that's where you really need to, when you're talking about architectures that scale up, and that's a lot about what we talk about on this show, you do need to be conscious that the database is not going to give you the magic abstraction that's just going to give you scale, right? And is that DAO layer in fact the place where you have to be conscious of some things?
I was just down under actually working with a client in Sydney, and we were designing a solution. Their architect had done a great job of kind of thinking through a lot of things and clarifying the problems. This kind of falls in line with there's a recent blogging article that's saying the microservices are just, some company has struggled with microservices and they're back to the monolith. And so we talked with this client down under, and we're talking through again, it came down to read and write patterns. And their querying part of it is going to be this new solution, this new API for them internally is going to be extremely read intensive and performance sensitive, very performance sensitive. We need sub 20 millisecond response times on a 99.9959 basis. I mean, otherwise it will potentially have severe impacts throughout the enterprise if we don't do that. So these are the performance requirements coming in. And so one of the first things we did from a design point of view is we carved out that read path and said, this is just going to be handled separately. We're going to think about it from our DAO level or from the way we're expressing it to the business. This SLA sensitive path here is going to be its own thing. And we will always have that separate. Now, it will still be part of a uniform API and there'll be other accesses in it, but at least as we're building this API and designing that, we know that that's the most sensitive area of that. And so we'll start with Graph, but we may need to go to a severe caching solution. We may need to do all sorts of shenanigans in the back end for that, but we don't want to impact the business or have them worry about that at all. So we at least presented a uniform API to them up front saying, here's what you're going to use, but understand that this area right here is probably where all the shifting in the back end is going to happen when we get into like building and testing the solution.
That's a great example and perfect. So I feel like you have a number of stories that you could probably tell about, ways that you've solved kind of these hard scalability problems for mission critical systems. So how about we continue this conversation on another episode? I'd love to hear some more examples from you and even to pick your brain on where you see enterprise data architecture going in the future. So
what do you think? Yeah, definitely. So I've got, I'll clear my schedule, Jeff. Just let me know what works for you.
Okay, excellent. Sounds good. Look forward to doing this again. Thanks everyone for joining us this week on the Distributed Data Show. Look forward to seeing you next week.
Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, make sure and subscribe so you don't miss a single episode.